So in this video, we're going to be talking about continuity and differentiability. This twinning has to do with when you do this with partners and the fact that as you go through it, you always get the same answer, which is kind of you twin. But we're not doing the twinning because you're at home by yourselves. So we're going to do this independently. So I'm going to do a couple problems for you. The first thing I'm going to do is add my name to the top of this document. All right. Okay. And so, first, I'm not going to do all of them, but I'm going to do a substantial amount. First thing we need to do is the first, I think six questions are all the same. I'll do 3 of them. And so when I look down this front page, I'm seeing parabola. It's pretty straightforward, but number 3 has a natural log in it, and we might kind of want to talk about that one. And then I'm also going to just do number 2. So I'm going to start with number 2. And just kind of remember what it is I'm doing now. For me, I like my paper tilted when I write. Let's see if I can just, yeah. I'll tilt my camera too, so you won't be able to it won't irritate you if it does. Okay, so find the value of k if possible that makes the function continuous at 3. So again, we're going to start with number 2 here. So at x equals 2, we want it to be continuous if possible. And continuous means there won't be any gaps or jumps or holes. And so what we're really trying to do when we talk about these problems is eliminate any jump in the graph. So what we're going to do is plug in 2 for each value of x and figure out what k is. All right. So we've got 3 times k times x minus x squared equals x squared, which is 2 squared minus 4k plus 4k times 2 minus 2. So you'll see that I have taken each value of x in the problems and replaced them with 2. And so that's all I've done so far. Pretty straightforward, no big deal. And then again, I'm going to be solving for k. So I end up with 6k minus 4 equals 4 plus 8k minus 2. So I'm just going to move everything together. I'm going to get minus 4 plus 2 minus 2 and minus 6k. And so I'll have negative 6 equals 2k and k equals negative 3. So I think k is negative 3. And if we were in class, you'd then compare with your neighbor and see if they also got k is negative 3. That's all you're doing. You want to verify that these are congruent. You're going to want to use Desmos for that. And so there are 2 Desmos calculators out there. I just wanted to kind of show you. The first one is this, which is the Desmos Scientific Calculator, which is really cool. Because then, you don't like have to know where anything is. So if I want to do square root, I just type that. And I can do square root of, say, 8. And I don't have to know. Or we have, of course, our good friend, this one. So I love Desmos. I think I've probably made that clear. If I haven't, I do. And so we're going to go here. We're going to have 3. And we said k was negative 3. X minus x squared. Okay. And that's only true in curly braces. X is less than 2. Okay. And so then I'm going to go down here and x squared plus 4 times negative 3 x minus 2 when x, again curly braces, x is greater than or equal to 2. So with Desmos, the greater than and less than signs are the period and comma, shift period comma. And then to get or equal to, you just push equal and it automatically switches it, which is really cool. Now you can't really see what's happening. So let's I zoomed out and look, see how we kind of have the one taking over for the other down here where they're equal to negative 22. So I've removed any jumping. That's all that's happened here. And that's it. That's all there is to it. Okay, so with that in mind, let's try number 3. I'm going to go ahead and zoom in on the paper just a little bit. All right, that looks good. So this one's a little bit more complicated because of the natural log. But the same thing's going to be true. I want, when I plug in 3 for x, there to be no jumping. So I'm going to have the natural log of 3 minus k plus 1. And I need that to equal 3 squared minus 2 times 3 minus 3. So what I want you to do is just take a minute and see what you can do with manipulating this. Just kind of clean up some stuff. It's pretty straightforward. If you want to pause, I'm just going to go. But so we're going to have the natural log of 4 minus k equals 9 minus 6 minus 3. So the natural log of 4 minus k is equal to 0. So then I have to ask myself the question, and hopefully I know, but if I don't, I can just kind of sit here and think about it. When is the natural log equal to 0? So when is the result, the y value, 0 of natural log? And the only thing I can remember is that 1 and 0 are tied together. So I can't remember if I put in 0, I get 1, or if I put in 1 and I get 0. So because I can't remember, that's where a calculator would come in really, really handy. So my good friend Desmos right here, really, really handy. So natural log of 0. Oh, that's undefined, so it's not that one. 1. Oh, okay. So when they take the natural log of 1, I get 0. So I just kind of remember that. The natural log of 1 is 0. Written that on my paper. And so the natural log of 1 is 0. And so that means that this stuff needs to be 1. So 4 minus k is equal to 1. I'm sorry about the blurriness there. Okay, and so 4 minus what is 1? Well, 4 minus 3 is 1, so k is 3. And again, I would verify this by using Desmos and making sure I was right. So go ahead and try 1 and 4, and you'll be all set. I'm going to go ahead and move on to one more on the next page, but you're trying 1 and 4. Should we do sine or e? I think we'll do sine. Find the value of k if possible that makes the function continuous at, just kind of go like that. I can move this up. Sorry. Continuous at x equals 4. So again, that means if possible, I'm going to plug in -4. So I have the sine of pi over -4. Whoops, I plugged in the opposite side. We're trying to find k, so we're replacing x minus 4 equals 6 over -4 minus 2. So the sine of pi over k is equal to -3/2, just simplifying that, minus 2 plus 4. I've just moved the 4 over. Okay. Nothing too crazy, I hope. And so I'm just going to clean up this side. So I've got -3/2 plus 2, which is the same as having, instead of 2, I could write 4/2, because that's 2, which is 1/2. So I am asking myself, when is the sine of pi over k equal to 1/2? Or in other words, when is the sine of any value, we'll call it theta, equal to 1/2? So the sine of theta is 1/2, and remember, this is periodness, and I need it to be a reasonable value, all the things, but when are they the same? And so sine is 1/2 at, circling, sine is y. So sine is 1/2 at 30 degrees. but we are in calculus, so we can't use 30 degrees. We're going to use pi 6. So if it happens in the first one, it's pi 6, but it could be any multiple of pi 6 because it's 1/2 here. It's also, y is also 1/2 at 5 pi 6, right before pi. So it could be either of these or any form of them plus 2 pi. So we got to kind of keep that in mind with the periodness. But those are our values of theta. And if it's, so what we want to do then is kind of look at where this is happening. So those are my two values, Decimus graphing calculator. I have the sign of, we're going to go with pi over 6. Because that's just an, oh, it's just going to be a number. That's kind of cool. Minus 4, wait, no, plus 4, plus x. X is less than negative 4. And the other one, x is greater than negative 4. And yeah, that's discontinuous. 6 over x minus 2. Okay. So even though it's not, we just wanted to make it continuous at negative 4. So it's not continuous because we have an infinite discontinuity at 0. But pi 6, I wonder what would happen if I use 5. It'll still work. So it's all good. So it looks like any number would have worked, which is nice. It makes it easier. Okay, so back we go. Either of them is correct. I'm going to go just sit with this one. And so k over pi over k equals pi 6. So k equals 6. Because since it's just going to become a number, either one will work because I just need it to come out to 1/2. So either one will work. Okay? Makes sense how I found that? I'm going to leave you with 6 to do, which is a bit challenging because of e. Remember that e is an exponential curve. Looks like this. Okay? And actually, that's probably not steep enough. Like this. Okay. So, and this is 1, 0, 1. And then when this is 1, this is e. So it's 1 comma e. The case. Okay, and so those are kind of some ideas so that you know what you're dealing with, what you're thinking about. Okay, so that's how you do the first 6. And we'll do another video for the rest.